But what do you do if the equation that you're given is not in the correct form, is not in this y equals mx plus b form? Well, we're going to do some algebra on it to rearrange it first. So our goal is to get y on the left side of the equation by itself and move everything else over here to the right so that we can figure out what the slope and the y-intercept are. So I'm going to start by subtracting 5x's from both sides. That will leave me with 2y equals a negative 5x plus 8. Then to get rid of the 2, I'll divide every term by 2. This looks a little different from the way we've done it before, because usually you only have one term left by the time you get to division. But now that we have two variables, we don't have numbers that are actually dropping out. So dividing by that 2 leaves me with just a y on the left side, a negative 5/2 x, and 8 divided by 2 is 4. So my slope is negative 5/2, and my y-intercept is the point 0, 4. Graphing it, still the same as it has been before. I'll come up here to 4 on the graph, and then my slope has me falling 5, running 2. Then falling 5 again, and running 2. And we'll go back to using the straight edge, since I can't seem to draw a straight line without one. In this next equation, I want the 3y to come over here to the left, the 3x to travel over here to the right, and then get rid of that coefficient that's on there. So I'm going to subtract 3x's from both sides. And then subtract 3y's from both sides. And then divide all of my terms by 3. Whoops, by negative 3, because I want that negative to go away also. So I get y equals x minus 1. Looking for my slope and y-intercept. The slope is this invisible 1 again that we can't see. So a slope of 1, or 1 over 1, and a y-intercept of 0, negative 1. Plotting that on my graph, there's the point 0, negative 1, and my slope says rise 1, run 1, rise 1, run 1. Here are my other 2 points. And last but not least, the graph. The next thing that we're going to talk about is lines that are parallel and lines that are perpendicular to each other. So parallel lines are lines that look like railroad tracks. They run right next to each other, and no matter how far they go in space, they're never going to cross one another. They're always going to stay separate from one another. So if you think about these in terms of slope, they have the same slope, because if their slopes were different, eventually they would intersect. So parallel lines have the same slope, but their y-intercept, the point at which they cross over that vertical axis is different. So mathematically, we explain this way. If m is equal to a over b, then the line that is parallel to m is also going to have a slope of a over b. Perpendicular lines are lines that intersect at a right angle, where each of the angles created by them is 90 degrees. And their slopes, you can see it with this, well, maybe not with these since these are 0 and undefined, but if I did a pair of lines that went like this, it might be easier to see a little bit there, that this one has a positive slope of, it looks like about 1 to 1. This one has a negative slope of negative 1 to 1. Or if I drew them a little more crooked, that one might have a positive slope of 1/3. The line perpendicular to it is going to have a negative slope, a downhill slope of 3. So the way we define this mathematically is that perpendicular lines have opposite, reciprocal slopes. Or to explain it mathematically, if the slope of one line is equal to a over b, then the slope of the perpendicular line is going to be a negative b over a, or the opposite reciprocal of the original slope.